Sorry. Shall we start, sir? Shibin?
Yes, sir. Good evening, everyone. Welcome to the second day of the webinar series conducted by Civil Engineering Department at SE in association with ICI and ASE Student Chapter. The topic for today is light gauge steel framing. But before we start the session, I request Dr. Saeed Jalaluddin Shah, the HOD of Civil Engineering Department at MESE, to present the welcome address.
A very good evening to one and all. On behalf of the Department of Civil Engineering, MES College of Engineering, Kuttippuram, I would like to welcome all the registrants and the participants of this webinar on light gauge steel framing organized by the ICA Students Chapter and ASE Students Chapter of the Department of Civil Engineering. We have had an overwhelming response in the registrations for this wonderful webinar series. It's my pleasure to welcome each and everyone who has joined here for today's session. Before we proceed, I would like everyone to abide by the following guidelines for the smooth conduct of the online session. Attendees are requested to mute their mic and turn off the camera. Please do not present your screen in between. Participants are free to post their questions in the chat box by mentioning their name. The organizing team will present the questions to the speaker at the end of the session. The speaker will answer all the questions if the time permits at the end of the session. Recording of this webinar is prohibited. Certificates of feedback form will be emailed directly within 2 weeks. Online webinar recording will also be available in YouTube. If you need any assistance during this done parallelly to accommodate more participants. Now, it's my pleasure to welcome our keynote speaker of the day, Engineer Er.Jeesh Venmarath, Managing Director for Shibin to introduce today's speaker.
Chapter, I would also like to thank him for providing us today's speaker. Now it's my pleasure to introduce our speaker of the day, Mr. Engineer Er.Jeesh Venmarath. He is a PMI trained project engineer. He started his earlier career life as a project engineer trainee in Kinfra Techno Industrial Park, Malappuram. Later began his first partnership venture, Formex Space Frames and Structure, which was a pioneer space frame company in Kerala. He is one of the few engineers who made their own signatures in the construction field. Wherever he laid his hands, he made a huge success and is still tasting each drop of it. He currently is working for Tata BlueScope on a time-bound PEV composite structural 2-storied warehouse project of 1 lakh square feet, which is to be completed in 128 days' time. He was the zonal president of Grace and was the charter president of ICI Gague chapter. He was very keen in extending his social ideas to everyone. He was also elected as the best president and outstanding assistant governor of Rotary International District 3202. I welcome you, sir, to deliver the webinar. So sorry, your mic is muted.
Yeah, thank you. A very good evening to all. So thank you, Mr. Shibin, ICA Student Chapter President of MES College of Engineering. I'm so happy and proud to see that ICI Student Chapter of MES College is doing a fantastic job where you have very, very well disciplined sessions throughout. And good to see the number of participants today. It is around 81 participants has been already registered. It's a very good count. In fact, I appreciate and congratulate the Civil Engineering Department for supporting you for this wonderful event. At the outset, let me thank the organizers of MES College of Engineering and ICA Student Chapter and ASE American Students Engineering American Students Civil Engineering Chapter, right? Yeah, for inviting for this event. It's always a pleasure to interact with the new generation engineers who is going to face the new generation challenges to bring the world to new normal, especially in this COVID situation. I take this opportunity to share whatever little experience and knowledge I've gained during my walk of professional career. I'll be happy if I could be able to motivate at least one mind to think in the direction of optimum usage of natural resources and to preserve and hand over those natural resources to the next generation. I believe that the LGSF technology will fall in this philosophy, and I would like to tell my story or my experience with LGSF structure. Let me do my presentation. Is it visible?
Yes, sir.
Okay, thank you. So my question for this session is, does our dream homes cost us our real life? So in what context I'm asking you is like with respect to the couple of natural calamities we are witnessing for the past consecutive years, and the kind of construction and the development of infrastructure that we are doing. Are we doing right to the society, right to the nature, right to the resources? In this context, the question is, does our dream home cost us our real lives? See, availability of our natural resources. Today in the newspaper, we read that more than 10,000 crores of infrastructure project as announced. The road network from Cochin to Kasaragod, it is more than 10,000 crore. More than 100 crore meter cube of raw material, natural resources is minimum required for this construction. If that has been absorbed, do we have any natural resources left to transfer to the next generation, or the current generation? Do we have enough resources to build our home? So the skill manpower, whatever we have right now, we were very much dependent. It's high time that we should think and develop our skill sets, and we should be self-sustainable with respect to the human manpower within the state itself. And as you all know, the time taken for construction, always we plan for say 1 year project, it always go around for 2 years or 3 years because of several reasons. First reason is with respect to the planning part and the red tapeism that what we have right now. Any project to be approved, it will take more than the construction time. So in these respects, we should, the role of AIMS is to develop a optimum resource handling facilities or optimum resource utilizing technologies to overcome these challenges. So when these factors have overruns, the cost of the construction is also escalating. So now what are the causes of all these factors? You have our, as I said, our natural resources depleting. Due to that depletion of natural resources and climate changes, we are having the effects of global warming. Because of these effects, we have a lot of natural calamities happening year by year. Our human resources are shifting from white collar job. They are looking for a white collar job. Nobody's want to do the regular activity or traditional activity, whatever we have learned so far. there is no upgradation of technology happening. Whatever the technology adopted by elsewhere in the world, we are very reluctant, or we are not supportive to adopt to that technology, just because we want to always be in a comfort zone. Whatever we learned, we want to do that and to adapt to that condition. We are not ready to think out of the box and go out of our comforts and do things. So the current economic issues we had demonetization, the GST factors, all those things also affected our resources. So you can see here, it's a view of a quarry. Okay, events that we are going to witness, and how long we can go with such kind of exploitation of natural resources. So being we are into construction and we need the infrastructure, no doubt about it. I'm not against for that, for the development, but we should use the resource properly. We should use the resource in a fashion where it should be very optimized. So what is the way out we are going to discuss? The way out is optimum use of resource and reuse and recycle. So here we always find that the steel is a material where we can have the optimum usage, and we can reuse it and recycle it. So how many times, n number of times you can reuse and recycle the steels without losing its property. You can modify it, you can add on different elements and have the relevant yield strength to the steel. So what are the advantages of steel? The steel is 100% recyclable. It is environment friendly with compared to the other construction material. The strength to weight ratio, you have a better strength to weight ratio, and it is you can build the structure for this toughest condition. You will have a better fire resistant and a stronger, and has shown an excellent material with respect to resisting the natural calamities. The improvement of steel with respect to galvanization or other corrosion control factors, you can improve the corrosion resistance of the steel as well. So here we are not talking just about steel, but our subject here is with light gauge steel frame structures. So what are the light gauge steel frame structure? Basically, the steel which we deal with 0.5 mm to 3 mm, which is comes under the bracket of light gauge steel frame structures. And light gauge steel frame is always, it's also called as cold form structures. So if you refer the codes, you will see it as a cold form structures. So let us see what are the advantages of light gauge steel frames, and in a combination of high density cement fiber board. Okay, and we have a very flexible design opportunity here. So you can design based on the future requirements, and you can have the design flexibility in the design construction. You can perfectly optimize the material usage. With the advantages of the IT technology and the software development, now we can model the structure like even a small element in a building can be designed perfect, can be optimized for its use. So since the sections are light, the wall thickness is also less. So we'll get around 8 to 10% more carpet area ratio, which adds on to the ROI of a building, return on investment of the buildings. and it's a step towards modular construction. You in this recent time, you might have seen all the videos from China where they have constructed around 9-storied building in 15 days or so. That was an approach towards a modular construction, which means the modules of buildings are finished in the factory itself and taken to the site, and it has been assembled. You'll get high quality and high precision. Whenever we talk about steel, we'll talk in millimeter, or the gauge we talk about in micromillimeters. So that is the precision what we can have in the steels. It can be able to withstand heavy wind loads. So wind loads and earthquake loads. So wherever we have a good the problem of having a disaster resilient structures, we can always use steel as a one of the elements for developing disaster resilient structures. The high fire rating of the building, you will get a superior acoustic quality when it is composited with high density cement fiber board or rock wool and glass wool, which I'll talk to you in detail. Handling and transporting is also very easy. You'll get a well planned construct site. Since the pre-engineered buildings are designed and all the minimal wastage is handled at the factory itself, and you'll have a finished product at site. So the site is also very planned, and the housekeeping of construction site is very easy. You can develop hybrid model. Steel can be combined, and you can utilize the strength of steel as well as concrete. So wherever in the tension zone we can use steel, and the compressive zone we can use concrete. So combining these two advantages, we'll get even lighter sections, and obviously you'll get a twice or thrice faster construction. You can avoid reworking cost, saves cleaning and post building cost. This is the main challenge we face here in all over Kerala. After construction, there are a lot of debris which we are facing challenge to dispose it. There is no, or the government has not come up with a solution how we can dispose the construction waste. Even though people are trying it by converting to brick or utilizing it for road, but no norms has been adopted that we should do like this for the construction waste. And since the structure is light, the foundation will be also be light in terms of dead load decreases, the construction size also decreases. And you require only semi-skilled workers at site, because all the engineering and production has been done from the factory. So at site, you need to only assemble it. So the skill level of labor also can be reduced. So during 2013, I've been able, I was fortunate enough to get exposed to such kind of construction in abroad. So I was working in Abu Dhabi as a consultant. So where I found a site wherein light gauge steel construction was happening. So my site was a building site with conventional construction, and the just adjacent site they were doing with Er.Jeesh. So we both started our foundation at similar time. But since it was a big palace-like structure, there was no access towards inside the site. So suddenly, after 2 days, when I went back to Calicut and came back to Abu Dhabi, the whole structure was entirely erected. So I was really fascinated about that particular construction. I started running behind it, studied what is the technology happening behind it. Went to their company. The company was called FrameCAD, and they were headquartered at the Middle East office was at Dubai. So when they sat with them, understood the construction. So and from looking from there, I thought this is the apt construction technique to adopt to our land, especially in Kerala, where we have limited resources. So during 2013, we conducted a survey along with Indian Institute of Management, Calicut, and identified that this particular technology is useful for our state. But what is the financial viability? So we identified, after doing a focus group discussion, we identified that we require at least 15,000 square feet to be constructed every month. So 15,000 square feet constructing every month is not a big deal. So it is hardly maximum, say, 2 lakhs a year, which a couple of buildings will take care of it. So we thought it might be very easy to accept this technology. Hence, we approached NIT Calicut for conducting a technical study or on technical aspects of the technology. So that time, Ganeshan sir requested me to conduct do a prototype project and understand the behavior of the structure. So the proposed prototype project was to execute it in different exposure conditions. So what are these three different exposure conditions we selected was, one was in coastal area that we selected Calicut as the first prototype project. So we identified a place near to Pallikandi in Pudiyappa. So there was a request from a lady to do a charity house for their requirement, and they have already done the foundation. So we thought, yes, it's an opportunity. Let us take it up. We approached a couple of sponsors to sponsor the house, but we got only 50% of the amount as a sponsor. We thought, let rest we'll take it as a to do this pilot project. So we started doing that project, and the second exposure condition we defined was at Ooty. That was a hill station, wherein the climate is also very cold, and you will get to know what is the thermal issues in that particular building. So corrosion we can address, thermal issues we can address from Ooty, and the third place we identified was at Coorg, where we get a heavy rainfall there, and it is always almost a humid, almost a wet condition. So we can study with respect to the moisture and water seepage, all those things. So these three projects we have executed during the period 2013-14. 2 years we executed 3 projects. So to further forward, we need to formulate a company. So we formulated a company called Eco Construct, and the brand ambassador for that particular company we identified as Honeybee as our brand ambassador, because I think Honeybee is the best structural engineer in this universe, because due to the specific shape of that honeycomb, the hexagonal shape is identified as the optimum shape, wherein it is built with using a minimum resources. So you'll get a stable shape for a mass housing project if we go for hexagonal shape. You can Google it with the hexagonal shaped buildings. So a lot of researchers, mass housing researchers has been gone with respect to this honeycomb shape itself. So anybody interested can Google that. So based on this, we formulated a company called Eco Construct in Bangalore, and started our operation. So I'll take you to a video on how the world is constructing with this technology right now. So after that video, I'll detail you on the experience, or I'll share the knowledge whatever we gain from our technology, our construction experience. The FrameCAD is one of the technology providers in the world. So you have, they're from New Zealand. You have Pinnacle from USA, Scottdale from UK. So few companies are available as a technology providers. So this technology, you cannot term it as a low-cost technology, but you can call it as a low-cost premium art, wherein you can get terrain-based design. You have a huge artistic or design scope for architects. So you'll get a better quality space with a low cost. So these are a few options of steel structures combining with light gauge steel frame and hot roll steels. So what is a specific need with respect to light gauge? So it is we need a section which is having good strength with sound properties, and you should be able to drill it. Loading on the wall should not be a problem. Sustainability for various geoclimatic conditions, safety is a factor, and faster construction is a factor. So this is a typical light gauge section where you have seen the production video wherein these sections are produced with forming couple of corrugations and shapes. These particular shapes give more stability to the structure. And you can also specify the where exactly you need to screw it. So the dimples are created in the section while doing the sectioning itself. The service hole is punched during the production. The notches for diagonal bracing and horizontal studs, everything can be done in a single production. So we'll just look at what are the construction processes. With respect to the foundation, we require a conventional foundation itself. We are on the process of developing a foundation solution, prefabricated foundation solution. Our company is currently going to be incubated in NIT for developing prefabricated foundation solutions, which I'll detail it to you some other time, how these kind of foundations can be achieved. So due to, as I told you before, due to the light weight of the structure, we require only light foundations. The sections can be assembled from site, or it can be made from factory itself based on the accessibility of the site. And here you can see a complete wall is going to lift by manual labors itself. You don't require a crane or a heavy equipment to lift the complete wall or a roof. Here you see that the roof has been erected by manually. And these are the erections of wall frames. And over the foundation, you lay a bottom track and just erect the structures with using fasteners like friction bolts or chemical anchors. And once it is all the walls and slabs are erected, you will get a perfectly networked and integrated structure, which is light, which is very stable, which can withstand good horizontal loads. And once your wall is done, we will erect a vapor barrier. Vapor barrier is nothing but a sheet wherein you have a aluminum or a zinc coating over it. So this vapor barriers, as the name says, it prevents the moisture coming into the building. Also, it prevents from UV radiation. So the heat can be much reduced with this vapor barrier. So it has two functions. One is with respect to moisture, and second is with respect to heat or UV radiations. So once you fix the vapor barrier, and then we'll have a high density cement fiber board claddings. See, these high density cement fiber boards are manufactured from, again, it's a recycled material from waste products like cardboard, cement bags. It is crushed and formulated with fly ash and cement and compressed to form the required density that we required for a board. So you will get various density boards for interior and exterior application as well. Yeah, the services, all the electrical, plumbing, air condition, HVAC, all services can be concealed within the structure itself. It can be concealed in wall through the joist, concealed in wall through the service holes, and over the ceilings through the joist. So now let us look into what are the pre-construction process. This is showing the production of a Er.Jeesh substructure. So, as in any project, we require a proper architectural drawing. We'll define the site location, the foundations, and then we require a proper architectural drawing. See, from these drawings, the structural engineers do is calculations on the loads. We analyze the structure, and the analysis input has been fed to a machine software. Okay, once the analysis is done, machine itself will automatically recommend a structure which is suitable for the particular loading condition. So this is the grid network where the software is proposed as a structure. But being engineers, being a structural engineers, our requirement is to ensure that the building behaves as like what we require. So we cannot take whatever the software suggests, because the limitation here is all these software are evolved from very developed countries. With respect to India, we have certain limitation. We have our own set of rules. So the budget for the construction allocated in our country is very minimal. So we should optimize the steel requirement. So to optimize it, we should develop our standard itself. So for that purpose, we should clearly evaluate what are the kind of loads that required and what behavior that structure should perform. So if you see this, this is a typical wall design wherein you have the different sections which has been labeled, coded by the software itself. So here we can evaluate loads on each member, and we can recommend or change the sections based on our requirement. So here we can see the proper production of a machine. As I suggested before, this is only one technology called FrameCAD. So during my presentation, I'm using FrameCAD as a technology provider. So I'm showing you only FrameCAD solutions. And now we'll talk about the post-structural work. So once the structure is completed, our main area will be to do the infill. So what are the priorities of this infill? The infill gives us the warmth from the weather. You can have rock wool as an infill material. You can use which is a mineral wool. You can use glass wool as a filler material. You can use lightweight form concrete. We have done all these permutation and combinations. We have experience with these all concrete. Also, we have developed a concrete called EPS concrete, extruded polystyrene concrete, which is nothing but thermocol beads. That's a glass wool, and this is the foam concrete. Yeah, roof also you can lay the foam concrete for weatherproofing. So let us take a typical section. Wherein, as I said, we require a perfect concrete to anchor the base tracks. So the base track or inverted the U tracks, it is laid on the ground. Before laying the track, we'll put a neoprene rubber pad. So what is this neoprene rubber pad? Neoprene pads, the property of this neoprenes are, it has a little fluid property, wherein you press in, if there are any loads come in one area, the other area gets expanded. So it allows the structure to damp the vibration. One. Second thing, it doesn't allow moisture to go towards the steel. So these are the two functions of a neoprene pad. And these neoprene pads are used for bridge bearing also. So we use a lot of neoprene application in construction. We use it as a water barrier for constructing water tanks. So once the neoprene barrier is laid over with the bottom track, and then we do a dash fasteners. It can be friction bolt. It can be chemical anchors. We have used these chemical anchors. You will get chemical bullets. So in glass bullets, there will be chemical filled in it. So once you drill a hole, so what with based on the design dia, we drill a hole and put these bullets and bolt it up. Once the bolt get tightened, the bullet breaks within the hole, and the chemical get expanded. So those are chemical anchors what we use. And over the structure, vertical structure is laid, and then over the erected, and over the structure we'll use a vapor barrier. And it is covered with two side cement board or gypsum board. So based on the performance of the required performance of the structure, we can use different boards. And we can have a wafer screws. Wafer screws will allow us to have a flat surface on the board cladding. And as I said, for infill, you use rock wool or foam concrete, which are commonly used. So again, external features, you can, as a typically in a conventional building, whatever external cladding you require, you can use. For interior also, endless possibilities are there. So any shapes and forms can be created with the structure. Now, as I told you earlier, this is one of the projects that we have executed in Ooty. Ooty, the location is in Lovedale, near to Lawrence School. So this was our first project in Calicut, which is executed on the right on the beach itself. So that was the project that we have executed in 2013. And being the first project, we also had a lot of setbacks. And the project also had a lot of challenges with respect to we are not getting the right amount of screws. See, one box of screw was missing, and we had to get sourced locally itself. So locally, we purchased the screws, stating that that is an anti-corrosive screw. So 150 screws was corroded, and now we are going to try the fatigue analysis of the structure. So after 7 years, what is the kind of corrosion that had happened? We had a leaking problem in that building because of our ignorance in certain standards in workmanship. So I think that is a blessing right now. In fatigue analysis, you can understand the behavior of the structure. So right now, after once the company starts incubating in NIT, we'll be able to identify all these challenges. So I have a request to your civil engineering department, wherein a couple of challenges that we are going to overcome, or we would like to overcome, is with respect to the design optimization of the software. So we should generate our own design programs, develop a software for the same. And also I said we are doing something in line with prefabricated foundations, where we are going to propose to use soil anchoring techniques. So a lot of geotechnical information is required. So I would love to have a interaction with the technical people, or the much senior peoples in your college activity as well. So looking forward for a good future association with respect to developing these or overcoming these challenges. So that's all for my presentation. Thank you for patient hearing, and thank you for the time given. So I hope I've been able to transfer some knowledge to you people, and I'm not a good speaker as such, but I hope I've been able to share my knowledge with you. Thank you.
Students can pose their doubts on chat box.
Yeah, I can see one doubt posted by Babu sir, stating that, sir, is there any as the wind load on the light steel frame can use deflections? Yeah, and then that is the record height right now. So that was the interest. Definitely, I love to share it with you. I've asked why is it due to. I believe it is the cost and B അവരിങ്ങനെ വെള്ളത്തിലേക്ക് മുന്നിലുള്ള അയാളെ പ്രോജക്റ്റ് കംപ്ലീറ്റ് ചെയ്ത് തീർത്തപ്പം ഞങ്ങൾക്ക് 25-30% കൂടുതലായിരുന്നു പ്രോജക്ട് കോസ്റ്റ്. അപ്പൊ 30% കൂടുതൽ പ്രോജക്ട് കോസ്റ്റ് എന്ന് പറഞ്ഞാല് I hope you are comfortable with Malayalam, right?
Yes,
Hello?
sir.
Okay. അപ്പൊ 30% പ്രോജക്ട് കോസ്റ്റ് കൂടുതൽ എന്ന് പറഞ്ഞാൽ ആൾക്കാർ അതിന് പോകാൻ റെഡിയല്ല. അതും ഒരു പുതിയ ടെക്നോളജി എക്സ്പീരിയൻസ് ചെയ്യാൻ റെഡിയല്ല. സോ ഞങ്ങളുടെ ഫീസിബിലിറ്റിയിൽ ഞങ്ങൾ കണ്ടത് ആ സമയത്തുള്ള ലാസ്റ്റ് 5 years, അപ്പൊ 2013 ലാസ്റ്റ് 5 yearsലെ കൺസ്ട്രക്ഷൻ കോസ്റ്റ് എടുത്ത് അനലൈസ് ചെയ്ത് ടെക്നോളജി വിൽ ബി അറ്റ് പാർ വിത്ത് ആ അത്ര ലെവലിൽ വന്നില്ല. ബട്ട് നമ്മുടെ ചീഫ് മിനിസ്റ്റർ ആണ് ഈ ടെക്നോളജി നമുക്ക് വളരെ നല്ലതാണെന്നും നമ്മളെ കേരളം ഇതിനെ അഡോപ്റ്റ് ചെയ്യണമെന്നും ഐഡന്റിഫൈ ചെയ്തത്. എന്നിട്ടാണ് ചീഫ് മിനിസ്റ്റർ ലൈഫ് മിഷനോട് പറഞ്ഞു ഈ ടെക്നോളജിയിൽ പ്രോജക്റ്റ് ഇംപ്ലിമെന്റ് ചെയ്യാൻ. ഇൻ അനദർ ഒരു 6 months time you will be able to witness few multi-storied buildings. ലൈഫ് മിഷന്റെ ഇതിന്റെ അകത്ത് കുറച്ച് മൾട്ടി സ്റ്റോറിഡ് അപ്പാർട്ട്മെന്റ്സ് ബിൽഡിങ്സ് തന്നെ നിങ്ങൾക്ക് ഒരു 6 മാസത്തിനുള്ളിൽ കാണാൻ പറ്റും. So gradually technology is picking up. I hope I addressed your point, right? Sibin?
Yes, sir. Thank you.
Okay, fine. Next question is, which type of foundation would you use for these building on poor soft soil? See again, selecting the foundation depends on the nature of soil or end value of soil. If it's definitely we can try for raft foundation. Since the weight is low, you can utilize raft foundation, but detailed soil analysis has to be conducted, and then only you can select the type of foundations. Then Mohammad Hashim has asked, is light gauge steel frame technology is same as like Maiwan technology? See, Maiwan technology is it is a system for for shuttering. Okay, Maiwan shutters are used for doing monolithic structures. So both are two different technology. Maiwan is for concrete and light gauge is for steel. Is that clear? Any doubt with Maiwan? Hello. Mr. Mohammed Hashim?
Yes, sir. Yes, sir.
Okay, thank you. Next, Risham MS. Where are the sections available in light gauge? And where are these specifically put in use? See, these sections are manufactured in India by two companies. One is with JSW and other one is with Tata BlueScope. Again, Tata BlueScope is a company where the Tata Indian company and BlueScope is an Australian company. Both had collaborated together to bring in a lot of light gauge steel frame structures. And this is your second point in that question. And where are these specially put in use? It is put in use for especially for building constructions. In India, we are using right now only for low rise, below 15-meter building, which is around 3 to 4 floors. It is generally used, but in Kerala, I think 2 projects is coming up with 7-story buildings. Ms. Geeta Venugopal, these type of building will be easily affected by lightning. Is it, sir? No, madam. It is not like that. Obviously, we have lightning arresters, and even in concrete also, the lightning it can happen. It is also having steel within the structure itself. So, with respect to lightning, there are couple of papers available over the net. So you can search cold form steel, wherein you'll get a lot of papers with respect to lightning. So I didn't see any issues with lightning. And Srisham has again asked, I meant the type of sections and their use. Can you detail it again? I didn't get you the question. Type of sections means it is basically thin sections from 0.5 mm to 3 mm, and the yield strength is ranges from 350 MPa to 550 MPa. Also, you have a galvanization coating ranging from 250 GSM to 375 GSM. Srisham, your question is clear?
No, actually, I was trying to ask you what are the types of sections that are available in the case of light steel.
Okay, fine. That sections right now it's available as we have C sections, U sections, the Z purlins, hat sections. There are different sections available, but U and C are the major sections we use for buildings. For pre-engineered warehouses and all, we use Z sections, hat sections and all. Okay. Like we have I section, yeah, okay, correct. I hope this question is clear, right?
Oh, yeah, now it's clear.
Okay. So other than corrosion, is there any durability issue with these frames? See, there are this technology has been utilized. I think it is almost 30-40 years. So durability issue, it can be resolved with a proper selection of sections with respect to the structural designs. So durability is also not a factor of concern. The life, what they say is it's a 100 years of life. And Mr. Mohammed Hashim, would it be economical and faster if this technology is used for mass construction, some projects rather than residential houses? Very good, relevant questions. See, currently our Prime Minister has put a global housing challenge. he has identified a few technologies, 6 different technologies, and he has given the challenge to the construction engineers to do the high-rise building with 3 different technology, and whoever finishes fast and in good quality will get 1 crore rupees as reward. So that challenge is happening right now. That construction is going to get complete in another few months' time. So we can understand after once it is over, we can understand what which technology is best suited for us at this point. This is conducted by BMPTC. So you can go visit the BMPTC site and gain more information on it. Yeah, Shibin has shared a feedback link. Good. You're dealing it very professionally. Good to see that. Thank you, sir. All very. Thank you for the opportunity, Babu sir. I'll text my number here. So any further doubt, please feel free to contact me, or you can email me. I'll on the chat box. I'll share my email ID also.
So now I request Yedu Surya, Joint Secretary of ASC Student Chapter MEAC, deliver the vote of thanks.
A graceful evening to our most valued chief guest, Mr. Er.Jeesh Venmarath, our HOD, Dr. Said Jalaluddin Shah, my faculties and my students. It's my privilege to propose a vote of thanks for this session. On behalf of the entire civil department of MES College of Engineering,